In the last video, I showed how the sum of the terms of the infinite series 1, 1 by 2, 1 by 4, 1 by 8 equals 2. But after making the video, I realized something. The answer 2 is actually not the interesting part. The interesting part is that we solved an infinite problem using just one equation. To find the sum S of the terms of this series, and I'm writing it down again. We divided both sides of this equation by 2. So the left hand side of the equation becomes S by 2 and the right hand side of the equation becomes 1 by 2 plus 1 by 4 plus 1 by 8, and since it's an infinite series, it goes on. So we have got two equations when initially we had just one. So this is our first equation and this is the second equation. Notice something strange? This is almost the same series. The original series contains a smaller copy of itself. So basically this part of the original series is same as the value of S by 2 that we obtained from the second equation. So we can write S is equal to 1 plus S by 2. That is why the trick works, not because the answer is 2, because the series contains a scaled version of itself. What if the answer wasn't 2? Say if we had to find the sum of a different series. So for example, if we had a series with terms 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 and so on, and this was an infinite series, in this case, how do we find the value of S? So once again, we divide both sides by 3. We get S by 3 on the left hand side, and on the right hand side we once again get 1 by 3 plus 1 by 9 plus 1 by 27 and so on. Once again we have these two equations, equation 1 and equation 2, and we can subtract the second equation from the first one to get a third equation. And if we solve this, we get S is equal to 3 by 2. The answer has changed, but the trick hasn't. It is the same trick that we used previously. Now let us generalize this idea. Say we have to find the sum of an infinite series where consecutive terms have a ratio R. So let's say we have to find the sum S for a series whose terms are 1, R, R square, R cube, and so on. To find the sum of this series, what we can do is we can multiply both sides by R. So on the left hand side we once again get R times S, and on the right hand side we get R plus R square plus R cube plus R raised to the power of 4 and so on. We once again have two equations 1 and 2, and as we did previously we subtract the second equation from the first one. And we get this answer. So basically the same idea works for any number between 0 and 1. As long as R is less than 1, this will work. This idea appears throughout mathematics. A large object contains a smaller copy of itself. This is the same idea that is useful in fractals, recursion in computer science, geometric series, and certain physical processes. These are just some examples. When I first solved this series, I thought the interesting fact was that the answer was 2, but the interesting fact is that the series contains a smaller copy of itself. That is all for today. Thank you for watching. Bye.